Before I go any further, I need to correct something in that headline, because being straight with you matters more than getting a dramatic hook. As of the most recent official monitoring reports, Mount Rainier is not currently showing new signs of unrest. Its alert level sits at normal, its color code at green, exactly where it's sat for years. But there's a real, recent, and genuinely significant story buried underneath that calm status report. One involving the largest earthquake swarm ever recorded at this specific volcano. A helicopter mission flown directly into its summit craters to figure out what was actually happening underground. And an official government ranking that places this mountain above every other volcano in the United States, for one very specific, very sobering reason. This is the real story of Mount Rainier, why it's officially classified as the most dangerous volcano in the country, what actually happened during last year's record-breaking earthquake swarm, and why the true danger here has almost nothing to do with the kind of eruption you're probably picturing. If you want the accurate version of stories like this instead of manufactured panic, subscribe now, because understanding the real risk here actually matters if you live anywhere near it. Let's start with why Mount Rainier holds the specific title it holds, because it's not what most people assume. The U.S. Geological Survey maintains something called the National Volcano Early Warning System, a formal ranking of every volcano in the country based on a combination of factors: how likely it is to erupt, and separately, how many people, homes, and pieces of critical infrastructure sit close enough to be affected if it does. Under that system, Mount Rainier is classified as a very high threat volcano, and it consistently ranks at or near the very top of that list, not primarily because scientists think it's likely to erupt soon, but because of exactly what sits in the path of its most dangerous hazard if it ever does. Here's the detail that actually explains everything about why Rainier gets treated so seriously. When people picture a dangerous volcano, they usually picture lava, or an ash cloud, or a dramatic explosive blast. Rainier's real threat is something quieter and, in a lot of ways, more insidious, called a lahar. Essentially a fast-moving concrete-like slurry of volcanic rock, ash, ice, and water that can race down a mountain's valleys at speeds of 20 to 45 miles an hour, and in some cases even faster. Mount Rainier carries more glacial ice than any other single mountain in the contiguous United States. And that ice sits directly on top of rock that's been chemically weakened and altered by centuries of volcanic heat and acidic gas, rock that's essentially been turned into something closer to loose clay in certain sections of the mountain's upper flanks. When enough of that weakened rock and ice gets mobilized, whether by an actual eruption or just as importantly by nothing more than a large landslide with no eruption involved at all, it can generate a lahar without any warning tied to typical volcanic activity whatsoever. And unlike most other dangerous volcanoes in America, Rainier sits directly above heavily populated river valleys that drain straight down toward the Puget Sound region, an area now home to hundreds of thousands of people living, working, and raising families, directly on top of the exact same ground that previous lahars from this mountain have already covered more than once in the past. If a story built on real USGS data instead of manufactured panic is the kind of thing you want more of, drop a like on this video right now. It genuinely helps this content reach more people who'd get value out of it. To understand just how real that risk actually is, you have to look at Rainier's own geological history, because this isn't theoretical. Roughly 5,600 years ago, a massive lahar known to geologists as the Osceola mudflow swept down from the volcano, and by the time it finally stopped, it had traveled all the way to what is now the Puget Sound, burying an area that today includes major population centers, with volcanic debris in some places measuring dozens of feet deep. That wasn't triggered by a large, explosive eruption in the way most people imagine a volcanic disaster unfolding. It was primarily the result of a massive collapse of already weakened, hydrothermally altered rock on the mountain's flank. More recent, smaller lahars have occurred in just the past few centuries as well, and modeling by the USGS shows that a lahar of even moderate size, following the same paths as these historical flows down river valleys like the Puyallup or the Nisqually, could reach populated communities in well under an hour from the moment it starts moving, arriving far faster than most people could realistically evacuate if they waited for visible warning signs before starting to move. The Osceola. Mudflow isn't the only historical warning sign either. A smaller, more recent lahar known as the Electron mudflow swept down Rainier's western slopes roughly 500 to 600 years ago, again apparently without any confirmed accompanying eruption, burying areas along the Puyallup River Valley under debris, in some places more than 10 feet deep, in a region that today includes real, currently inhabited towns. That specific pattern, a lahar generated by slope failure rather than a violent explosive eruption, is exactly why Rainier's hazard planning can't simply rely on watching for classic pre-eruption warning signs like rising magma or dramatic gas changes. A large enough landslide, triggered by something as comparatively mundane as prolonged heavy rainfall saturating already weakened rock, could theoretically generate a dangerous flow with very little advance notice. independent of whatever the volcano's deeper magmatic system happens to be doing at the time. To understand just how many people actually live inside these historical flow paths today, consider that the valleys draining Mount Rainier, including the Puyallup, the Nisqually, the Carbon, and the White River valleys, are now home to well over 100,000 residents, along with major transportation corridors, schools, and other critical infrastructure, all sitting on ground that geological mapping confirms has been covered by lahar deposits multiple times over the past several thousand years. That's the actual concrete reason emergency planners in Pierce County and across the surrounding region treat Rainier's lahar risk as a genuine ongoing planning priority, running periodic evacuation drills in schools and communities located within mapped hazard zones, specifically because the lesson from Rainier's own geological past is that this isn't a hypothetical scenario dreamed up for a worst-case simulation. It's a pattern the mountain has already demonstrated more than once, long before anyone was around to record it happening in real time. That's precisely why USGS scientists and Pierce County emergency officials built something specific for this exact mountain, a dedicated lahar detection and warning system consisting of a network of ground vibration monitors installed directly in the river valleys downstream from Rainier's most hazard-prone slopes. If those sensors detect the specific seismic signature of an actual lahar beginning to move, an automated alert gets triggered almost immediately, giving downstream communities and emergency management agencies as much warning time as physically possible before a flow could arrive. It's one of the only systems of its kind built specifically around a single volcano anywhere in the country, and it exists precisely because Rainier's combination of glacial ice, weakened rock, and a huge nearby population creates a genuinely unique level of risk that most other volcanoes in America simply don't carry in the same way. If you found this more informative than alarming, drop a comment and let me know. It genuinely helps me figure out what to cover next. It's worth directly addressing the comparison most people immediately think of here, because Washington's other famous volcano, Mount St. Helens, tends to dominate the public imagination whenever Cascade volcanoes come up in conversation, thanks to its catastrophic 1980 eruption. But St. Helens and Rainier actually represent two very different kinds of danger. St. Helens demonstrated what a large, genuinely explosive eruption can do. A lateral blast that flattened forests for miles, an eruption column that sent ash across multiple states, and a death toll that remains the deadliest volcanic event in modern U.S. history. Rainier, by contrast, has had a comparatively quiet eruptive history over the past several centuries, with its most recent confirmed eruption having occurred roughly 1,000 years ago, and no indicators currently suggesting anything close to a St. Helens-style event is on the horizon. What makes Rainier top the government's threat list anyway, even sitting quietly for centuries, comes back entirely to that lahar risk and the sheer number of people now living in its path, a combination that simply doesn't exist in the same way anywhere else in the Cascade Range, including at St. Helens itself. Now let's talk about what actually happened last year, because this is the part of the story that's genuinely current and genuinely newsworthy, even if the situation has since calmed back down. On July 8th, 2025, at just before 1:30 in the morning Pacific time, seismic monitoring stations beneath Mount Rainier began detecting an earthquake swarm, a cluster of many small earthquakes happening in rapid succession in the same general area. Earthquake swarms aren't unusual at Rainier on their own. The mountain typically produces around 9 to 10 small earthquakes a month, even during completely normal background conditions. And noticeably larger swarms tend to occur once or twice a year without indicating anything close to an impending eruption. What happened in July of 2025 was different in scale from anything scientists had recorded there before. At its peak, the swarm was producing more than 40 located earthquakes per hour. By the time monitoring teams from the Cascades Volcano Observatory and the Pacific Northwest Seismic Network had finished analyzing the full event, roughly 7 weeks later, they had located more than 1,350 individual earthquakes, officially making it the largest earthquake swarm ever recorded at Mount Rainier, surpassing the previous record set back in 2009 in terms of total number of events, overall event rate, and total energy released. Despite that record-breaking scale, one detail stayed constant throughout the entire event, and it's the single most important fact in this whole story. The USGS kept Mount Rainier's official alert level at normal and its aviation color code at green throughout the entire swarm, from the very first earthquake through its gradual decline weeks later. That's not an oversight or an attempt to downplay something serious. Volcano alert levels aren't based on earthquake counts alone. They're based on the underlying cause of that seismic activity, and everything scientists observed pointed toward a specific, well-understood, and comparatively benign explanation, one that had nothing to do with magma moving toward the surface. To actually confirm that explanation rather than just assume it, USGS gas geochemists partnered with the National Park Service to fly a helicopter directly over Rainier's summit, carrying sensitive gas detection equipment specifically to sample the composition of steam and gas escaping from small vents near the summit craters called fumaroles. Comparing volcanic gas chemistry over time is one of the most reliable ways scientists have to distinguish between two very different underlying processes: magma actively rising and interacting with the volcano's plumbing system, which tends to change the ratio of specific gases, like sulfur dioxide, in a detectable way, versus a purely hydrothermal process, where underground water gets heated and begins circulating through cracks and faults in the rock without any fresh magma being directly involved at all. The gas measurements gathered during that flight supported the hydrothermal explanation. According to the USGS, the swarm was most likely caused by hot water and steam circulating through and lubricating pre-existing faults deep beneath the volcano, a mechanism that's been documented in previous, smaller Rainier swarms going back years, rather than any indication that molten rock was pushing its way toward the surface. By late August of 2025, seismologists reviewing the accumulated data determined that earthquake activity at Rainier had gradually declined back down to what's considered typical background levels for the volcano, and the Cascades Volcano Observatory formally noted that the underlying hydrothermal process that likely caused the swarm might still be continuing at levels too subtle to produce detectable seismicity, meaning a small chance of brief, minor upticks in activity in the following months remained on the table, without that representing any kind of ongoing emergency. It's also worth understanding a bit more about why hydrothermal earthquake swarms happen at Rainier at all, because the mountain's internal plumbing makes it particularly prone to this specific kind of activity compared to many other volcanoes. Rainier sits above a genuinely active geothermal system, meaning groundwater seeping down through cracks and fractures in the rock gets heated by residual warmth from the volcano's deeper magmatic system, then circulates back upward, sometimes under significant pressure. As that heated water and steam moves through pre-existing faults, it can effectively lubricate those fault surfaces, making it easier for small sections of rock to slip past each other and generate an earthquake, even without any actual movement of magma anywhere nearby. This same basic hydrothermal system is also responsible for the visible steam plumes regularly seen rising from Rainier's twin summit craters, a completely normal, long-documented feature of the mountain that predates any of last year's seismic activity by decades. Scientists specifically watch for changes in that steam and gas output, alongside earthquake patterns and ground deformation measured by GPS stations installed around the volcano, because a genuine shift toward magmatic unrest would be expected to show up as a coordinated change across multiple of these independent measurements simultaneously, rather than an isolated spike in earthquakes alone. During last year's swarm, the broader coordinated shift simply never appeared, which is a large part of why scientists remained confident throughout that they were watching a hydrothermal event rather than the earliest stages of something more serious. That brings us to right now, because as of the most recent weekly status updates from the Cascades Volcano Observatory, every monitored volcano across the entire Cascade Range, Mount Rainier included, alongside Mount St. Helens, Mount Baker, Glacier Peak, and Mount Adams, remains at normal background levels of both seismicity and ground deformation. There is currently no indication of any renewed unrest at Rainier specifically, and nothing in the available data points toward an eruption being imminent in any meaningful sense of that word. For anyone actually living in or visiting the valleys downstream from Rainier, the practical guidance from emergency officials is fairly straightforward and worth repeating clearly. If you're ever in one of the mapped lahar hazard zones and you feel prolonged, unusual ground shaking, hear an approaching roaring sound similar to a fast-moving train, or receive an official lahar warning alert, the correct response is to immediately move to higher ground, away from the valley floor, rather than trying to outrun a flow along a road or trail that follows the same low-lying path the lahar itself would take. Local schools and communities within these zones regularly participate in evacuation drills specifically built around this guidance, and Pierce County's emergency management resources include detailed maps showing exactly which areas fall within mapped hazard zones for anyone wanting to check their own home, workplace, or regular travel routes. None of this is meant to suggest an evacuation is likely anytime soon. It's meant to reflect the same basic principle that applies to earthquake preparedness in any seismically active region. Understanding your specific local risk and knowing the correct response in advance costs very little and can matter enormously if the rare moment it's actually needed ever arrives. So why does a story about a volcano that's currently sitting at completely normal activity levels still matter enough to spend this much time on? Because the actual sober scientific consensus about Mount Rainier has never really been about predicting exactly when the next eruption will happen. It's about the fact that a huge, densely populated region built directly downstream from a genuinely hazardous mountain, one that doesn't necessarily need a dramatic eruption at all to produce a catastrophic lahar, deserves to understand that risk clearly, honestly, and without either downplaying it or exaggerating it into something it isn't. The 2025 swarm mattered specifically because it was a real, measurable, unusually large event, thoroughly investigated using both seismic and direct gas sampling data, that ultimately confirmed the system built to detect a genuine change in Rainier's behavior actually works exactly the way it's supposed to. Scientists noticed the anomaly immediately, deployed real resources to understand its cause within days, and correctly identified it as hydrothermal rather than magmatic, all while keeping the public accurately informed throughout, rather than either hiding the event or overstating its significance. So what does all of this actually add up to? Mount Rainier remains, by official US, government classification, the most dangerous volcano in the country. Not because an eruption is expected anytime soon, but because of the specific, well-documented combination of massive glacial ice, geologically weakened rock, and a huge nearby population that makes its primary hazard a fast-moving lahar, uniquely capable of reaching hundreds of thousands of people with very little warning, with or without an actual eruption ever occurring. Last summer's earthquake swarm was genuinely the largest ever recorded there, and scientists took it seriously enough to fly a helicopter directly over the summit to investigate it properly. What they found was reassuring, a hydrothermal process, not magma on the move, and the mountain has since settled back into the same normal background activity it's shown for years. The real, ongoing story here isn't a volcano waking up. It's a genuinely well-monitored, well-understood hazard, sitting quietly for now, with a detection and warning system built specifically because the people living closest to it deserve every possible minute of advance notice if that ever changes. It's worth noting where Rainier actually sits alongside the small handful of other volcanoes that share its very high threat classification, because the list is short and telling in its own right. Mount St. Helens itself remains on that same list, alongside Alaska's Redoubt volcano and a handful of others scattered across the country, each one earning that top classification through its own specific combination of eruptive history and nearby population exposure. What sets Rainier apart even within that already narrow group is the sheer scale of its glacial ice combined with just how directly its river valleys funnel straight into one of the most densely populated metropolitan regions in the entire Pacific Northwest. It's genuinely difficult to find another volcano anywhere in the country that pairs quite that much ice, quite that much geologically compromised rock, and quite that many people living directly in the path of the resulting hazard, all in one place, which is exactly why it tends to sit right at the very top of the list year after year, swarm or no swarm. If stories like this, accurate, current, and honest, about what the data actually shows rather than what makes the best headline, are what you come here for, subscribe to this channel and turn on notifications, because Rainier is still being watched closely, and you'll hear about it here the moment anything genuinely changes. Thanks for watching, and I'll see you in the next one.